Okay, this unit that we're going to look at is more or less split into two. And the first part, we're going to actually look at a new way that we can actually output data using something called system.out. And in the second part, we're going to delve a bit more into the object-oriented side of programming. So now we've completed assignment 1, we know the basics of Java. What we need to do now is think a little bit more about how we can actually create more object-oriented programs, and that includes what we're going to do today, which is all about writing programs with more classes, more than one class in it. But first, we're going to develop the window cleaner system on top of what we did in the previous lectures. We're actually going to add a little bit more outside of the original specification, but what it will allow us to do is utilize a new method called printDirt, which is going to be an improvement on the original output of the data, particularly because we were using 2 for loops to output the amount of dirt on each of the windows, and it was a bit long-winded to actually output everything using string concatenation. So what we're going to do is output the state of the whole building to a separate window, and it allows us to view almost the entire window in a single go, rather than having to keep clicking the OK button all the time. Previously we used user.message, and it allowed us to output data a line at a time. Then, if you remember, we clicked OK, then we got another line of data, then we clicked OK, and then we got another line of data. It's okay, but it's not the best in the world. What we need to do is basically build up, as I've mentioned here, something called an output report, so we can send the output to a separate window and look at it separate from the program itself, or a separate window like the user.message window. And we can actually do this in Java using something called the console window. Sometimes it's called the terminal window. There's an example of how it looks. This is what we're going to put into use today. It allows us to provide output into a separate window. We can output data to it a line at a time, and it gives us a more, what I've said here is a much more flexible approach, in that we're not constricting ourselves to using the user class. We can use the console window, and it gives us a more permanent output of the state of the data that we're using in the program. Because you can see in this one, we've actually got, in this particular case, we've got some scroll bar windows, and it allows us to basically see permanently the data that's being used, and we can keep it there, because once we've sort of scrolled past it in either direction, let's say we've scrolled in that direction or scrolled in that direction, what we can do is we can scroll back to it, so we can have a more permanent record of what it is we're actually trying to do. So in Java, what we've got is a pair of commands that we're going to use as an alternative to the user class, and the part of a pre-built library called system. And because they're pre-built in, we don't have to do any commands, we don't have to add any commands to the top of the class, because they're already added in there for us. We just use them as standard commands. And the 2 commands that we're going to use are called system.out.println, which allows us to write a string to the console window, but system.out.println adds a return onto the end of the line. So it writes a line out and then adds, or effectively presses return at the end of the line. We've also got one called system.out.print, which obviously doesn't have the ln at the end of the word print, and that just outputs a line of data as a string, but it doesn't press return at the end of the line. And the rules about mixing strings and data items that we use with the user class with the plus symbol is exactly the same with system.out. So we can mix strings and data together like we did with the user class in exactly the same way. So what we're going to do is, as a bit of an example, we're going to use those commands to output the content of the original window dirt array that we did in the last example of window cleaner. And what we're going to do is, instead of using the user class, we're going to use the same 2 for next loops to go through each of it, to visit each of the windows in the building. But what we're going to do is we're going to use the system.out commands in order to output the data to the console window, and then we'll be able to see the building sort of complete, as opposed to having to keep clicking OK at the end of every line. And this is how we're going to do it. You might or you might not remember how we looked at the code to visit each of the elements of an array in a 2-dimensional array. And I don't want to dwell on that too much, because obviously we're worrying about system.out as a method of visiting each of the elements in a window. But what we've actually got at this point is 2 temporary variables called I and j, which we've got here. I'm going to use those to try and remember the floor and the window numbers. We've got the system.out.println, which is just a header, so we don't need to worry about that. And then we've got, from last time, we've got our 2 for next loops. We've got the outer loop, which runs on this one. And then we've got an inner loop, which runs on this one. In fact, it runs to about there. And what we've got is the ability to use the outer loop to go from top floor and keep going as long as it's greater than or equal to 0. So what we're actually doing in this particular example here, we're actually going through the array backwards. That's so that we can output the data in the correct order. Now, if you remember from the last lecture, we said that when we created 2-dimensional arrays manually, what was happening was it was actually creating the array upside down. We can fix that by going through the array backwards, like we've actually got in this example, because we're going from top floor, which will be the highest, and keep going as long as the value of I is greater than 0, i.e. it's not at the ground floor, and we're actually going backwards. In the sort of inner loop, what we're doing is we're just doing that in the normal way. We're moving from left to right, so we're starting from 0 and we're going on as long as we're not at the last window in the column. So we're going to go incrementally. We're going to go, in this case, we're going to go forward, and we're starting at 0, and as long as we're not at the last window, we're going to go in increments of 1. So in this case, our window is going to go 0, 1, 2, 3, 4, and so on. And then what we're going to do is we're going to cycle through each floor in the outer loop, which is this one, and then in the inner loop, while we're on that floor, we're going to cycle through each of the windows incrementally, and then use system.out.print to output the value in the array at I, which is the floor, and j, which is the window on that floor, with a space after it. So we're effectively going to go visit 0, floor 0, visit window 0, 1, 2, 3 until we get to the end. Then come to the end of that column and then do a system.out.println, which will basically put in a carriage return to move us on to the next line. Then we then visit the next floor. Again, all the windows on that floor, so you've got this situation where you've got the inner loop, which is going round like that, and then we've got the outer loop, which is going round like that. and we're going to visit each of the floors, visit each of the windows on each of the floors, and use system.out.print to output each line of data with a space in between. And then we get to the last window, we do a system.out.print line, which is going to allow us to press return, and then we move on to the next floor. And we'll have a look at that in this example that I'm going to show you now. Okay, so I've downloaded the Window Cleaner 6B project from the VLE, and I've opened it up in BlueJ. The first thing you're going to notice is that things are a little bit different, because while we've got the actual class for the window cleaner and user, which we've used for quite a long time now, we've actually got classes for the cradle and classes for the building. I don't want you to worry about those too much yet, because everything that we're going to demonstrate in this example is based in the one building class. So we're just going to concentrate on the building class for now, and then we'll worry about the other classes later on when we talk about some of the more complex stuff. So what we're going to do is we're just going to look at the building class code. There's our class definition for building. We've got a top floor and last column, and we've got our 2D window dirt array, and we have two parameters to our building for total floors and last column, which is for the number of windows, and our random number generator, which we've used in our import statement at the top. And basically we just create new arrays, a new array to store the window dirt, and then we use a random number generator from 0 to 3 to just put an amount of dirt on each window. So a lot of that we've covered in the stuff that we've done before. It's the print dirt method now that we've got an actual physical definition for here, which we're using to output the state of the building using system.out.print and system.out.println. And what we've got is our method print dirt, and the output, just like the code in the PowerPoint slide, our outer loop for going from floor to floor, from top to bottom, backwards, and our inner loop, which will visit each window from 0 to the last one in increments of 1. In the inside loop, we use system.out.print to visit the array at each location with a space after it. And then once we've visited all the windows, we use system.out.println just to add a carriage return onto the end, and then we go on and go to the next floor down, because we're going from top to bottom, remember. So what happens is, I don't need to run a window cleaner. I'm just going to create a building with two parameters for total floors. So I'll just do a 4x3 or something like that. If I do a 4x3, and it generates a building. Now, if we were to do it the old way and we inspect, if you remember, when we have an array, we can double click it, and then we've got each of the dimensions on each of the floors. So if I wanted to see the dirt on this floor, for example, I could double click that, and then we could visit each one. Now you imagine it's a 4x3, so we're going to have a lot of these windows open, which is a bit of a mess. Yeah, it can get difficult to try and understand what's going on. Hence the reason why we wrote the print dirt, because what it does is it goes through the two-dimensional array, and it allows us to output the state of the building into a terminal window using system.out.print for each line, and then system.out.println to add a carriage return at the end. As you can see there, we've got no dirt on the windows on the ground floor and no dirt in the first column, because that's where the cradle moves up and down. Okay, so that's just another little tool that we can use to help us organise and view our data, especially when we're using two-dimensional arrays. What we need to worry about now is when we get into the sort of hardcore object-oriented programming, particularly as you've already noticed in Window Cleaner 6B, we're now starting to write programs or look at programs where we've got more than one class. So what we're trying to do now is write programs where the data and methods that belong to individual objects in our program are actually enclosed within each separate class. So what we're doing is trying to separate out the main objects that belong into our programs. So what we've got in the example of 6b is we have a window cleaner class. The window cleaner class has all the information in it that relates to what a window cleaner can do. We have a cradle class, which contains all the information and methods that a cradle can do. And then we add a building class, which had all the information in relation to what a building can do, which isn't very much. So what we have to do now is look at each of those classes and make some decisions on how we actually create those classes and how we create relationships between them. Now, if we were to, as we've been doing sort of since day one, write programs where everything is in one place, in one class, we have a situation which is called close coupling, which isn't considered very sort of organised object-oriented program, because different objects in the real world shouldn't have access to all the information for any other object. So what we do is we have to separate our objects into separate classes, and we only let other objects access information in a very controlled way, and we do it through a principle called information hiding, or another term that's used quite a lot is encapsulation. And the way that encapsulation works is only letting other classes access information in a very strictly controlled way. And the way that we do that is that we modify, well, we don't make any modifications as such, but what we do is we create classes in a clever way. We create them in two ways inside the same class. We have something called the interface, and the interface is the interface between the class and the other users of that class. So what do we actually let other people allow us to see or allow us to use? Then there's the implementation, which is the actual nuts and bolts of the class and how it actually works. So what we do is we let people see and use the class through a very strict interface. So we only let it do things through the interface. The implementation is the core nuts and bolts, and we don't let people mess around with the implementation. All right. In fact, it's probably better we don't let them access the implementation, because technically then it will let them make changes, which is sometimes what we don't want to do. And the way that we do it is through this system called information hiding. And it's based on the notion that if you are going to build a very large system with lots of classes in it, you're probably working in a development team. Now that development team will be working on different classes, maybe in different parts of the world. And what we need to do is allow them to access parts of the classes that you're working on to let them get the information that they need, but don't let them have access to everything, because potentially there might be problems if they make any changes. So what we do is we have two new keywords that we're going to start introducing as part of our class definitions. One is called public, and that's what we allow other people to access, so that's our interface. And then we have private, which is where we hide things from other people and other classes because we don't want them to make alterations. So it's a public interface and a private implementation. Okay? Think about it. Let's take a very simple analogy. All right? You want to borrow a book from your friend. You know that they've got it. Last time you were around the house, you saw it. You wouldn't go to their house, break in through the window, or break in through the door, or climb down the chimney to get it, there has to be a legitimate way that you can gain access to the information in that book. And the only way that you can legitimately access it is by knocking on the door and asking if they can borrow it. So the interface for that little analogy is the fact that you can knock on the front door and ask to borrow it. But the implementation is what you wouldn't have access to. The fact of the matter, it might be in the bookcase, it might be in another room, it might be upstairs in a bedroom. The implementation is being completely hidden from you. The interface, which is the front door, and the ability to access that book through the front door, will only be allowable through you. So the interface is public, i.e. the front door. The implementation, like the room that it's in, the information that's held in it, that's completely private. And the way that we sort of create these access modifiers is by adding the words public and private to our class implementations. And there's a couple of rules that you need to know about adding these access modifiers. First of all, we've mentioned that the interface is public. So, public interface elements are only given to methods. Okay, so the rule of thumb always is that methods that you want accessible to other classes must be public. Okay. Private is given to any other class implementation. So, instance variables must be private. And methods that you don't want to form as part of the public interface, they must be declared as private as well. Okay? They're called access modifiers, and there are others as well. There's one called protected, but we're not going to look at those. But public and private are actually important factors in defining your interface and your implementation to a class. So, we've got a situation here. We've got our window cleaner class, and there's obviously a relationship between the main class, this window cleaner class. We've got a building and we've got a cradle. So what you need to be able to do is look at each of these and be able to identify what you want to be public and what you want to be private. What do you actually want these other classes to be able to access? And you need to think about it quite carefully, because if you think about it, the window cleaner must have access to the cradle because the window cleaner stands in the cradle, and they need to be able to access certain functions in order to access the cradle. The cradle needs to be able to access some elements of the building, and without that the cradle wouldn't know whether it's at the top or whether it's at the bottom. So it's a bit of a challenge. Yeah, what you need to be able to do is sort of think, well, what does that need to be able to access in order to define whether it's public or private or not? So what I've done is identified, first of all, any of the methods that need to be accessed by something else. So for example, the window cleaner needs to be able to access these methods of the cradle in order to be able to operate it. So a window cleaner must be able to hit the up, down, left and right buttons, and it must be able to open and close the gate, otherwise the window cleaner can't use it. The window cleaner must also be able to access print dirt to be able to see the dirt, and the building must also have access to clean windows, because what we're trying to do is get the window cleaner to be able to get the dirt off the dirt value off the building in order to work out whether it needs cleaning and whether we need to charge for it. So we've got a number of instance variables that are in the interface, for example in Cradle and building and things like that, and we've already established that we shouldn't be letting other methods access those variables from inside other classes, because you create close coupling. You create a sort of a permanent relationship between those two methods, and it's not classed as good object-oriented design. So we have to have a very controlled way that we allow variables to be changed by other classes in other methods. And the way we do it is by accessing values indirectly. Okay, and an example of how that works is, we're going to have a look at it in a minute anyway, is look at the mwindowDirt instance in building. At the minute we access it using mBuilding, which is the name of the object or the class, and the name of the array with the floor and window number on it. It's not the best way of doing it, because we're actually breaking the rule that we've just talked about. We're letting the window cleaner class access another class, an array in another class directly, which is bad form. We shouldn't be doing it. What we should be doing is writing a public method inside the building class, which allows us to get that value, and then it will return that value back because we've asked for it through a public method, and it will return those values back through parameters. So what then we can do is say, well, I want to get the value of window dirt on that floor in that window in that building, and it should return it to us. And the thing is that it's a lot cleaner way of doing it, because we're using a public method in order to get it, rather than accessing the actual array itself. Because if I made any changes and something went wrong, it would be very difficult for me to actually access that stuff. So we have to sort of slightly change the inner workings in order to get it to work, but we'll have a look at that in a minute. So what we do is we have two different sorts of methods. We have public methods that allow us to access data in other classes, and they're called accessor methods. Okay, and we generally start the method name with the word get, because it allows us to get data. So get window dirt, get top floor, get last column. And get methods, or getter methods, or accessor methods will always return data back. Getter methods will allow us to access privately declared variables from inside other classes. All right, that's an important thing to remember. We might at some point want to change a variable that's in another class, which is perfectly fine. But again, through the same principle, we shouldn't be allowed to access a variable from inside another class directly. We need to use a method to modify that variable through the use of a parameter. The technical term is a mutator method, because if anything mutates, it changes. And we normally start those methods with the word set. So set window dirt, set age, set date of birth, doesn't make any difference. We know those as mutator methods. So, looking at what we've done before, have a look at the setup that we've just had for the 3-class system, and list the accessor and mutator methods for our new window cleaner interface. Okay, just pause the video, have a couple of minutes and see what you get. Okay, so what we're going to do is we're going to try and apply that set of rules to window cleaner 6C. And what we're going to do is we're going to add the accessor and mutator methods, and We're going to have public and private access modifiers to our methods as well, and we're going to see how that changes the way that the program works. So this is going to be quite a complex definition and description, but it'll give us an idea of how we can use coupling and public and private access modifiers to build better programs in Java. Okay, this is what we've got so far. We have in our Cradle class our standard methods for up, down, left and right, and open and close gate, but we've got two accessor methods. Now accessor methods will be to allow us to get the current floor and the window number, which will be privately declared in there, and let, for example, the window cleaner access that information through those methods, not directly through there. Subsequently, the building will have methods to get the value of top floor, because that will be privately declared. The last column, again, will be privately declared, but we want to be able to get the value of the dirt, either get the window dirt at a particular floor and position rather than accessing the array directly, or be able to, when we first set things up, set the window dirt at a particular position, again through a mutator method rather than accessing the array directly. Okay, so let's just have a very quick look at how that would work. Right, so this is Window Cleaner 6C, which we've downloaded from the VLE. It's the three classes that we're concentrating on for Window Cleaner 6C, Cradle and Building. The user class we know about, that's just got the standard user.message and other things, so I'm not going to worry about user class. I'm going to start off with the two methods, Cradle and Building, and then we'll go to Window Cleaner 6C and look at how that works in there. Okay, so I'm not instinctively worried about knowing the ins and outs of the Window Cleaner class and how it works to a minute detail. I'm more worrying about the interface, the implementation, the access modifiers, which are the things that I'm worried about in this particular lecture anyway. So we'll have a look at the Cradle class first, and we'll look at some of the changes that have been made to it. Okay, so in our class definition, first of all, notice the instance variables now have private access modifiers. Okay, so anything outside of a Cradle class cannot access those variables directly. We will need to either use a getter or a setter. We initialize things, and then our standard go up is the same. You know, if the gate's open, we can't go up with the gate open and think, or go up floor, go down, go right, go left. Open gate, that's the same. Close gate, that's the same. The only difference that we've got is we've got two new methods. One called get current floor and one called get current window number. Now, they are public. Okay, as are some of the others actually. Got open gate and closed gate, they've all been declared public. Now, if it's been declared public, that means an object outside of a Cradle class can access that method. These two are special because these are what we call accessor methods. They are public methods which return a value back. They're not voids in that they don't return values. They actually return the value of m current floor. Now, if you remember, right at the top, m current floor is private. It's private because we don't want anything to be able to access that variable directly. The only way you can do it is by creating an accessor method, which we use get to indicate, and we return the value of m current floor to where it's needed. We don't let a class access that variable directly. We need an accessor method. Okay, in this case, get current floor will return m current floor because it's an integer. Get current window number works in exactly the same way. We return the value of m current window number because it's privately declared. We can't have direct access to it, but we have a return parameter of an integer which allows us to return what's in that value to where it's called from, and we'll see that a little bit later on. So the cradle class is relatively straightforward. If we go to the building class and open that in the editor, again we've got a few bits and bobs which we need to look at. For example, our instance variables for top floor and last column, they are private, and the two-dimensional array of windows called window dirt, that's private as well. So again, if any object outside of a building class wants to access either the top floor or the last column value, or the amount of dirt on the windows or the window dirt array, then they cannot access those values directly. They are declared private. So we will have to write accessor and mutator methods in order to get those to work. In our constructor, we ask for a top floor and last column number of windows. That works in exactly the same way. We set it up, we generate the random numbers, we set random integers for the window dirt. It's exactly the same. But in this example, we've got a mutator method. Okay, we know it's a mutator method because the method is called set something. This one is called set window dirt, and it needs three parameters, which is the floor number, the position or the window position, and the amount of dirt. Now we can't access that array directly. We can't touch it because it's private. So what we need to do is write an accessor method. We pass the data in that we want in order to change the value in the array, and then we set the array inside the setter. So the array at floor number, position number, which is passed in, let the value be equal to the dirt that's passed in as well. And we do that because we have to do it through a publicly accessible setter or mutator method rather than directly accessing the array itself. We've also got a getter. We've got an accessor method called getWindowDirt, where we get the floor number and the position window number. We return the value of an integer, which is the amount of dirt on the window, where we return the amount of dirt in the array at position floor window or position. We've also got two accessor methods for the top floor, in which case we return an integer from the method called getTopFloor, which is the, again, privately declared top floor variable. We've also got one for getLastColumn, which is the last window number, and again we return the privately declared last column variable as an integer to where it's called from. And because they're public, we can call those from outside of this class. We cannot access anything that's privately declared from outside of the class. We need getters and setters. Technically, printDirt, as an aside, that's been declared as public as well, so we can actually call that from outside of the class as well. So let's have a look at the window cleaner. As you can imagine, this is quite big, but it's got a lot of the concepts that we've been learning about over the past few lessons. And first of all, we have everything privately declared. Our instance variables, the charges, the base charges, the floor factors are all privately declared. We also have an instance of the cradle created inside the window cleaner class because the window cleaner uses a cradle. And we've also created an instance of a building class because obviously we need to clean a building. In our constructor, we have set up the charges for basic, floor factor, multiplier and cost per wipe. They are parameters to the constructor, and we set those up. We initialize total charge, and we create an instance of a cradle because the window cleaner needs to use a cradle. So that creates the reference to the cradle class. That actually creates a new cradle for the window cleaner, which we call mcradle. Some of the methods now have changed a little bit, and it might be worth, outside of this little lecture, having a look at how this information now is accessed, because we're now getting hold of values from other classes through the use of accessor and mutator methods. And this is actually one of the wipe window is one of the classic ones. As you can see, calculating the standard charge for a window now is finding out the base charge, which is in the window cleaner class, but the current floor is available by calling the get current floor accessor method that lives in the mcradle class, which is an instance of the cradle. The value of window dirt at a particular point in time in the while loop, you get hold of that through an accessor method written in the building class called get window dirt, get current floor, get current window number. So we're accessing that data as an external entity. Likewise, we're actually setting the window dirt. When we wipe the window, we have to reduce the amount of dirt on the window by 1. So we have to call set window dirt in the mBuilding instance at that particular location by getting the window dirt from that location and taking one away from it. So we get the window dirt at that position, knock one off, and then set it to one less. So there are many instances. For example, when we clean the windows now, we get the current floor by calling the current floor accessor method from the cradle. We don't get it directly. We get the top floor from the building with a getter. We get the current window from the cradle. We get the last column from the building. So there are instances now where we don't access data directly. We use accessor and mutator methods in order to get the information that we need. So we have learnt a lot of new terms in this, especially in the second half. We do need to sort of now start thinking, as our programs are getting a little bit bigger, about our information hiding, creating what we call loosely coupled classes, and using the principle of information hiding and the use of public and private access modifiers to control access to individual data elements within each class. Remember that the interface to a class is all about what things are accessible publicly, and the only things that should be accessible publicly are the accessor and mutator methods that we use to access and change the data in a class. The variables in any class should now be declared as private. No other class instances should be allowed to access variables or arrays directly. We should only use the accessor and mutator methods, getters and setters if you want to call them that, to be able to access those through those methods.